Now the second problem, which is based on the nodal analysis. Find the current through a 100 ohm resistor. That means we have to find the current through this 100 ohm resistor. The first step in the nodal analysis, we are considering the different nodes. Suppose this node is V1 and this node is V2. It is given in the circuit. And we are considering the one reference node which is connected to the ground terminal. Here we are not considering it because it is having the 0 volt. Then, and in the nodal analysis, second step is we have to consider the directions of the current to the branch at different nodes. So simply, and we are considering the actual directions of the current. So see here, this voltage is having the positive and the negative terminal. We know the current flowing from the positive terminal. So the through the 20 ohm resistor, we are considering the current is I1. See here, this is the current source and the direction of the current source is also given. So therefore, suppose this is the I2 current, and these two current I1 and I2 are meeting to the node V1. Suppose we are considering the current which is outgoing through the 30 ohm resistor is I3. Then this I3 current is coming to the node V2. Again here, this is the 40 volt source and having the positive terminal here. So current will be flowing like this from the positive terminal, and again it is coming to the node V2, and suppose it is I3 current, and these two current are meeting to the node V2 and distributed or spread out in the through the 100 ohm resistor, and suppose it is I4. Sorry, here we are considering it is I4 current and it is I5 current because I3 we have considered already. Then we are applying the KCL at the different nodes. The next step is apply KCL at the different nodes. So first step is, suppose we are applying KCL at node 1. So similarly, see here, we have considered in the previous example as we are considering the incoming current are positive and the outgoing current are negative, or simply the incoming current is equal to outgoing current is the KCL. But for the simplification, we are considering the incoming current is positive and the outgoing current is negative. Here the I1 is incoming current, I2 is incoming current, and I3 is outgoing current. So simply it is I1 incoming current, therefore it is positive. Again I2 is incoming current minus I3, which is equal to 0 because I3 is the outgoing current. So now we are applying or finding the different currents by using the Ohm's law. So see here, the I1 current which is flowing from 60 volt to the V1, we are considering the initial voltage minus final voltage divided by the resistance, and through the 60 volt source current flowing from minus to plus, therefore it is plus 60 minus V1 divided by 20. This is the current flowing through the 20 ohm resistor. Simply initial voltage minus final voltage divided by the resistance. We are subtracting the final voltage if we don't know the polarities of the final voltage. If we know the polarities of the final voltage, then we have to consider the direction of the current and the polarities, as we have seen in the different conditions. Now for the I2 is directly given, it is 1 ampere. So simply it is plus 1 minus I3 which is going from V1 to V2, that means initial voltage minus final voltage divided by 30. So simply it is V1 minus V2 divided by 30, and which is equal to 0. By solving this equation, we get the final equation will be like this: 0.8 or 0.83 V1 minus 0.033 V2, which is equal to 4. Suppose this is first equation. By solving this equation, we get first equation. Then the next step is we have to apply KCL at the node 2. So simply apply KCL at node 2. So at node 2, voltage we are considering it is V2, and as we are considering the incoming current positive and the outgoing current are negative, here the I3 and the I4 are the incoming current. So simply both the current I3 and I4 will be plus minus I5 which is equal to 0, because current I5 is the outgoing current and we are considering it is negative. Then for the I3, the equation will be I3 current flowing from first node to the second node, or it is initial voltage minus final voltage divided by the resistance. Therefore it will be V1 minus V2 divided by 30. Then for the current I4, current flowing like this is the initial voltage 40 volt source and this is the final voltage, but through the initial voltage current flowing from minus to plus, therefore it is, we are considering it is plus, so it is plus 40 minus final voltage, it is V2 divided by the resistance is 50. Then minus I5 current which is flowing from V2 to the reference node, that means initial voltage is V2 and the final voltage is reference voltage which is 0 volt. So simply initial voltage V2 minus final voltage which is 0 divided by the resistance is 100, and which is equal to 0. By solving this equation or by simplifying this equation, we get the final equation will be like this: minus 0.033 V1 plus 0.063 V2 which is equal to 0.8. Suppose this is second equation, and by solving these two equations in the scientific calculator, we get the values of V1 and V2 will be like this: V1 is equal to 67.25 volt and V2 which is equal to 48 volt. These are the two values we have get by solving these two simultaneous equations. Now the actual question is, we have to find the current through the 100 ohm resistor, and the current through the 100 ohm resistor is I5, and we know the equation for the I5 which is initial voltage minus final voltage. Initial voltage is V2 minus final voltage is Vc, which is reference voltage, divided by the resistance is 100, and which is equal to V2 is 48 minus Vc is 0 divided by 100, so which is equal to 0.48 ampere. This is the final current which is flowing through the 100 ohm resistor. So it is 0.48 ampere. This is the final answer. Thank you.